Hi everyone, welcome back to our channel. I am Saloni and hope you all are doing well. Today, in this video, we are going to be discussing about one of the most interesting and fundamental concept of JavaScript, which is also the most commonly asked question in the interviews, and that is closures. In this video, I'll walk you through what closures are, why do we need them, and we will go through some of the real life use cases of closures where they play a very important part. So without much further ado, let's get started. So, what are closures? Closure is basically a concept in which an outer function scope is accessible through an inner function. What does it mean? That means if you have defined a function within a function, then the inner function would have access to the outer function scope, even when the outer function has been executed. Wow. How does it do that? According to MDN, closure is a combination of function and the reference to its lexical environment. What do you mean? What is lexical environment? Before diving into closures, let's first understand the fundamental and the key of the closure, and that is the lexical environment. In JavaScript, we have scopes. Scopes basically defines how far a variable is accessible or visible in the program. We have different types of scopes in JavaScript: global scope, local scope, block scope, function scope. Then there is some special type of scope, that is lexical scope. So what is lexical scope? So according to the definition, in a lexical scope, the inner function have access to the variables and parameters defined in the scope of its outer function. Let's see how a lexical scope is created. Let's understand lexical scope with the help of a program. For that, I'm creating a function called outer, declaring a variable x in it with the value 1. Let's nest this outer function with a function inner, which does nothing but tries to consume the value x defined in the outer function init through a console log. Now let's call this inner function in outer and now execute the outer function. Let's see the output of it. So yeah, you can see that inner function was able to access the value x which was defined in the outer function. Let's try and nest it a little further and maybe call this function innermost. Maybe give this function a local variable as well. Call it by. Call this function here as well. So yeah, here you can see the variable x is accessible in the innermost as well. So the variable which I had defined in the outer function scope is accessible everywhere within its scope. And that, my friend, happens because of the lexical scope. So when the innermost function is getting created, with that a special object gets created as well, called lexical environment. We will come back to that later, what exactly it is, but for now, let's try to understand it as an object which holds the properties of the local scope of a function. So for each function, lexical environments get created. So when the line number 13 gets executed, the innermost function tries to find this variable x in its lexical environment, but could not find it because it is not defined in its local scope. So it tries to find in its parent's lexical environment in which it is defined. Could not find an inner function as well because it is not defined there either. So inner function tries to find in again up the ladder in its parent's lexical environment. Here in this case, we have outer function, and voila, it found it. So we have a successful output of line number 13. But there was one catch in the definition of lexical scope. Let's recall what exactly was it. The lexical scope says that the variables or parameters defined in the outer function scope are accessible within the inner function. So let's try to understand the catch with the help of an example. Let me create another function called outside here, and it does nothing but prints I'm outside. Call this function with an outer function. Now what I'm trying to do is I'll try access variable x and outside. Okay. So what do you think? Will this get executed or will it throw an error? We have a variable x here. We have called a function outside, inside, outer function. But do you think that this variable would be accessible within outside? Let's see if it is. No. It gives a reference error. And why? So according to lexical scope, for the inner function to have access to the outer function's scope, it has to be defined within the outer function. So here, the inner function is defined within the outer function, but outside is only being called. Its definition lies in the global scope. It is not defined within the outer function. So the lexical scope chain doesn't work for the outside function. The outside function was not able to access the variable x, which was defined in the outer function's local scope, because the local scope chain of lexical environment did not lead it to this variable. And why is that? Because when outside tried to find this variable x in its local lexical environment, it could not find it there. So, as we discussed before, it tries to look for it in its parent's lexical environment in which it is defined. So, it is defined in the global scope, not in the outer function scope. So, in the global scope, it tries to find for this variable x, and it could not find it there because no such variable is defined in the global space. So, it returns a reference error. So, we have talked enough about the lexical environment. Let's take one step ahead and try to see what lexical environment object structure looks like. So according to ECMAScript specification, the lexical environment object has the following components. The first is the environment record. Environment record is nothing but all the variables and functions defined within the local scope of the function. Those are kept in the lexical environment under environment record. And there's also a reference to the outer function's lexical environment. So we have talked about this example. Now let's see how the lexical environment object looks like for this example. So when this innermost function executes line number 13 and tries to find this variable x, so the structure of the lexical environment object of the innermost function looks like this. It has a local variable y is equals to 2 in its environmental record. And it has a one special thing called outer, which does nothing but points to the lexical environment of the parent in which it was defined, and that is the inner function's lexical environment. And this is how the whole chain is connected. So when line number 13 was getting executed, the execution asks for the variable x from the innermost lexical environment. It says it could not find it there. So it goes to the lexical environment of the inner function and tries to find it there, but could not find it there either. Similarly, the chain moves ahead and it tries to find it in the lexical environment of the outer function. It found it there. So we have a successful execution of that line. But what if the variable x was not defined in the outer function as well? So the chain would have moved ahead to the global lexical environment. If the x was present there, we would get this variable in that particular execution. But if the x was not there as well, so the lexical environment there would have returned a null, which would have resulted in a reference error. So that was the overview of lexical environment. If you want to dig deeper into the concept, I will attach the documentation of ECMAScript in the description box below. So let's try and move back to what closures are and see how it leverages the functionality of lexical environment to preserve the data in the inner function even when the outer function has been executed. For that here, see this example. I've created a function called makeAdder which accepts a parameter and sets it to the variable sum which is defined in it. If it is available, it gets assigned to it. Otherwise, I assign default value called 0 to it. And it does nothing but returns a function which accepts this parameter and adds this value to the sum. This whole function does nothing but creates a cumulative sum of all the values which has been passed to the function which is returned by makeAdder. Which means if I add value, for instance 1 to it, it will return 1. If I pass another parameter, for instance says 2, it'll return me 3. If I'll add 5 to it, it'll return me 8, and so on. Now let's execute this function called makeAdder by passing a value 10 to it. MakeAdder returned me a function which I have assigned in a variable called adder. Let's try and execute this function by passing a value 2 to it, for instance. And let's run this. It returned me a 12. That means adder actually preserved the value which I had passed initially to makeAdder in the variable sum. And when I passed a value 2 to adder, it actually added 10 to 2 and returned me a 12. Let's try to run it again with the value 3. Wow, it returned me 15. That means again, it preserved the previous value which was returned, that is 12, added 3 to it and returned me 15. But since the makeAdder function has already been executed, the variable or anything defined in its scope should stop existing. As we all know, when the JavaScript engine tries to execute a function, it puts it onto an execution stack. And when the execution is completed, that function is popped out of it. So ideally, the sum should not have been existing, but it still did. Let's see how. Now let's look at this diagram to understand it conceptually. It might look a little bit complicated to you, but as we will move through it, you will come out of it understanding closures better. But before that, let's talk briefly about how execution in JavaScript works. Whenever JavaScript engine executes a function, it does that in two phases. First is creation phase and the second is execution phase. Now let's look at this diagram. The outer block represents the function makeAdder and the inner block represents the function adder, just like as we discussed in this example. When the JavaScript engine executes makeAdder, in creation phase, it creates a lexical environment of makeAdder function, which holds the variable x, sum, and some functional declaration if they are defined in the makeAdder. After that, it enters into the execution phase, where it assigns the values to its variables. For instance, here assigns value 10, which we passed as a parameter, to the sum. Now JavaScript engine passes this function to the execution stack, where the function gets executed. Once the execution completes, before popping the makeAdder out of the stack, JavaScript engine returns a scope, which holds the lexical environment of the makeAdder function, which is also called the closure scope, which will contain the variable sum, variable x, and if there were some other function declarations defined in it. With that, it also attaches this closure scope to the functions nested in it, which means the lexical environment of makeAdder gets attached to the function definition of the adder function. Let's see how. So here, when the execution of makeAdder starts, it creates a lexical environment with variable sum in it. And in the execution phase, the parameter 10 which we pass to makeAdder gets assigned to it. When makeAdder completes its execution, it returns its lexical environment as closure scope and attaches it to the function it is returning. In this case, adder. In adder, it attaches that closure scope. Let's see how. Let's run console.dir, which does nothing but print the properties of the object. Here, the function object. If we look inside it, and under the scopes, there are two types of scope which got created. One is the global scope, and the second is some special scope which is closure. Here, you can see what it did was preserve the sum that was the local variable of make adder with the variable which we passed as a parameter to it. Now, if we run adder with some other variable, it will consume this value, add this value to it, and will return the result. In this case, added 2 to the 10 and returned us 12. Now, as we all know that sum wasn't defined in the adder function, but somehow it was able to reach to the variable and was able to access the value to it. Let's see how. Let's go back to the diagram. So when adder function started executing, it does the same thing which make adder did. The execution context executes it in two phases. The first is creation phase, in which it creates adder's lexical environment, and in the second phase puts the adder function onto the execution stack to start its execution. JS engine, while executing, tries to look for the variable sum in the adder function's lexical environment. This is where the variable lookup comes into picture. Since it's not part of the lexical environment of adder, it will look it up to the attached closure scope of the make adder, in the same way we previously discussed about the lexical scope chain. If sum is found in the scope chain, the execution moves forward. And that is how the closure gets created. So guys, that was all about understanding closures. Next stop is why we need them and its real life applications. Knowingly or unknowingly, we all are using closures in our programming life. One of the real life example where closures can be used is publisher subscriber pattern in JavaScript. It's a design pattern that provides a framework for exchanging messages between publishers and subscribers. A publisher can have multiple subscribers. A publisher can notify the change to all the subscribers who have subscribed to it. Here is the basic implementation of the PubSub model which I have implemented. It has two methods, publish and subscribe. Using publish method, you can publish an event, and through a subscribe method, you can subscribe to an event. And all the events which you are subscribing to are saved in the events variable. Here you will see the subscribe method returns a nested method called unsubscribe. The unsubscribe method leverages the functionality of closure to access the index value of subscriber, which uniquely identifies it for unsubscribing. Line number 32, we have written the code to subscribe to an event called closure. And we have published the same event, and on line 37, unsubscribe from that event. Let's run this program. Here, when we subscribe to the event, it console.log at which index I have subscribed to it. When the event got published, it notified its subscribers, resulting in execution of this function, which returns I am the first subscriber and also consumes the value which was passed from the publish method. Now, when I unsubscribe to that event, you can see the same index is being consumed. Why is that? Because of closures. Because of closures, this unsubscribe method remembered the index at which the subscriber had subscribed to. So this was just one use case of closures. Other scenarios where you can use closures are module pattern, higher order function, currying, and when you want to delay the execution of something. Let us know in the comment section below if you want to know more about these scenarios. We will be happy to take them up in the next videos. So guys, that was all about closures. Thank you for watching the video till the end. If you have any queries or suggestions, do mention them in the comment section below. If you found this video helpful in any way, please like, share, and subscribe to our channel. Have a nice day. Bye bye.